What's cracking? Now that we've learned the closed interval method to determine the global maximum and minimum values for a continuous function on a closed interval, we are able to start looking at some application problems where we'll use this method to find the optimal way of doing something. And we'll start with an example. An office supply company sells markers and makes a profit of P of x equals negative 0.001x squared plus 8x minus 5,000 for selling x markers, where x is between 0 and 10,000. Find the maximum possible profit and determine the number of markers that should be produced. So what we're going to do first is we're going to go through and solve this using the closed interval method. But afterwards, I want to talk about why this function is what it is. Because it's really interesting. We often will get profit functions that are quadratic functions with a negative leading coefficient. This is quite common for different products. And I want to take a little bit of time at the end of this video to talk about why that's the case, just to give you a little bit of insight as to why this process ends up being really useful in different circumstances. So let's use the closed interval method. This is a continuous function, and we're given a closed interval. So what we need to do is we need to find the derivative so we can find any critical numbers and evaluate the original function at the critical numbers and at the endpoints. So for our derivative, when we are differentiating the first term, the derivative of x squared is 2x. And if we multiply that by the leading coefficient, that's going to give us negative 0.002x. And then when we differentiate 8x, that's just going to be 8. So this is going to be plus 8. And the derivative of our constant term is 0. So the overall derivative is negative 0.002x plus 8. That is never going to be undefined, so the only critical number is going to happen when that's equal to 0. So what we can do is we can add the x term to both sides. That's just going to make everything positive. And then if we divide both sides by 0.002 to get x alone, that's going to give us x equals 4,000. So our only critical number is 4,000. So we're going to have to evaluate our function at 4,000. We're also going to have to evaluate it at the endpoints of our interval, which are 0 and 10,000. Now, I am just going to use a calculator to make life easier. If we evaluate this at 4,000, our resulting function value is 11,000. If we evaluate this function at 0, the terms with x's go away, and we're just left with negative 5,000. And if we evaluate this at 10,000, our answer is going to be negative 25,000. And so if we look at these three function values, the maximum is going to be 11,000. And remember that this is profit, so our maximum profit is $11,000. And that is when x equals 4,000, but x is the number of markers they're selling. So this is when they sell 4,000 markers. That is our answer. Now, you might be sitting there thinking, well, won't they make more profit if they sell more markers? And the answer is that there's really a lot going on in creating this profit function that isn't visible until we dig into it. And really, profit is, here we're looking at as a function of how many markers they sell, but the number of markers they're able to sell is really a function of how much they charge for the markers. Because if they make the markers more expensive, there's going to be fewer people who are interested in buying them. But if they make the markers cheaper, they're going to sell a lot more of them, but they're not going to make as much profit on each marker. So it's more complicated than it looks. First of all, let's just give a very, very, very rough sketch of what this graph looks like. This is a quadratic function, and the leading coefficient is negative. So if we were to graph this, we would end up with a parabola that is opening downward. So let's get our axes and let's draw a parabola here. The y-intercept is going to be negative because we've got minus 5,000. So this is going to be, I guess I should have made the axes go further, but whatever. We're going to have a y-intercept that's negative, and then this is going to be a downward opening parabola. And remember that our end point on the right was at 10,000 comma negative 25,000, so it's even further down. This is just a super rough sketch, but I want to have a graph of the profit function, even just the general shape of it, so we can talk about what's actually going on here, because there's a lot going on here. Basically, there is some ideal price that they can set for the markers that is going to give them a healthy amount of revenue for each marker and also sell a lot of markers. But if they change the price in either direction, it's going to cause a decrease in profit. Now, if they make the markers less expensive, I don't have actual numbers here. Let's say $5 was the optimal price per marker. If they make the markers less expensive, like $2 or $1, what's going to happen is they're going to get more people buying these markers. So the number of markers that they sell is going to increase. However, the amount of profit they make on each marker is going to go down because they're selling them for less money. And what's going to happen is the profit's going to get lower and lower. And eventually there's a point where if they make the price of the marker less than it costs them to make it, they're going to start losing money because they're selling a crap load of markers, but they're selling them for less than it costs to make them. And that's why the profit ends up dipping into the negatives here, because they're losing money. Now, on the other end of things, if they make the markers really expensive, they're going to make more money per marker, but they're going to sell fewer and fewer of them. And in the end, that's going to hurt their profit, right? If they make the markers $100 each, they're not going to sell many unless they're absolutely magical. And there gets to be a point where they've increased the price so much that they're making a lot of profit individually on each one, but they're only selling a few. And we get to the point where they're not selling enough markers to make the money back that it cost them to produce the markers. And so again, we end up going in the red. We end up losing money. So if we make them too expensive, we're not going to sell enough and we're going to lose money. If we make them too cheap, we might sell loads of them, but we're going to be making less and less money off of them. And eventually, if we make it too cheap, we're in the red. But there is a nice sweet spot in the middle where we are maximizing our profit because we found the right balance to make it affordable enough that a lot of people want to buy them, but still cost enough that we're making enough profit on each of those so that we're doing decently. So this is often what profit functions look like. It could be markers, it could be laptops, it could be iPads. If you were to make iPads a lot less expensive, more people would end up buying them, so you'd sell more iPads, but the profit you make on each iPad is going to be less and less as you make it cheaper, and eventually there gets to be a point where you've made it too cheap, and even though you're selling loads of them, your profit is decreasing. And then, of course, you can't sell them for less than it costs to make them, because then you're in the red. But if we make it too cheap, we end up losing money because we're not making enough per iPad. And on the other hand, if you make them more expensive, you're going to earn more money per iPad, but fewer people are going to buy them. So you're going to sell fewer of them. And in the end, if you make it too expensive, not enough people buy them, and your profits get smaller and smaller. And eventually it gets to the point where you're not making enough money to stay afloat. And so companies do all sorts of market research to figure out what the exact price is so that they can sell the right number of iPads or the right number of objects at the right price and maximize that profit. There's so much market research that goes into it. And once all of that market research goes out into the revenue they'll make and then also the costs that it costs them to produce them, they're going to come up with some sort of a profit function, and maximizing that involves calculus, and that's going to tell them how much they should sell them for, how much they can sell, so how much they should produce, and that's going to help them with a lot of their business decisions.